So yeah, I'm with Ceco Concrete. I did get a Director of Equipment Resources attached to my title, so I'm over equipment as well as the engineering. So even more, connected into the formwork side of it. So I'm going to go over some very basic things on formwork systems and how that can be, how you look at the design while thinking about formwork to look at productivity. So our objectives for the session, understand what aspects of formwork systems lead to productive building designs. Then we're going to review several specialized formwork systems, and then learn what productivity gains can be made from implementing these systems. So the words that have been thrown out a lot are constructability, productivity, and efficiency. And they've all been thrown out as essentially the same thing. And really, they kind of get us all in the same direction. We're looking for square feet per man hour is essentially what we're trying to improve. But a little bit of differences, and I'm going to address them a little bit differently. I just need to turn it on.
That's what it's
So constructability, in general, is making things easier to use, or making it easier to use our resources. We just want to make it easier on the contractor, easier on the producer. So I'm coming from a contractor perspective, so that's what I can speak to. So for us, if it's easier, that's better. That's what makes it more constructible. Efficiency is using fewer resources to achieve what we're looking to do, and then productivity is getting more from the resources that we have. So really kind of two sides of the same thing. Thank you, Mike. But really all looking to how do we build more with less resources. So over a couple of presentations, this has came up earlier, of what it costs to make a concrete structure. Formwork cost is a very large percentage of that cost. So the cost of a concrete structure, and these things obviously vary. Formwork is 50 to 60% of the total cost of the concrete structure, not the building itself with everything, but the concrete structure itself. Concrete comes in at about 30% and rebar about 20%. And then the form materials of that are about 10 to 25% of the formwork cost. So of that 50 to 60%, 10 to 25% of that is the form materials themselves. That leaves a whole lot of the rest of it over for formwork labor. And that's really the thing that we're focusing on. It's the most variable of all of those things as well. A material goes in place. Material has a fixed cost once it's produced. Labor can be all over the place and change very quickly, and that's where we get all of our productivity gains. So we're going to talk about some systems that aim to do that, to force our labor down, so we can reduce that significant part of this cost. So there are three key factors we're going to talk about for each of these different systems. I think these are the three things that really will focus us into what we want to look at. So consistency is the first thing. It allows for reuse and continuity of process. I think continuity of process is sometimes something that gets left out of the thought process. We'll talk about that. Reuse and continuity allow for innovative solution. You can keep doing the same thing over and over again. You can get better at it, and then you can find solutions to make you better at those things. Standardization is our next focus. That allows for reuse from project to project. So within a project, if we can be consistent, that's great. Now, if I can go to another project and use that exact same stuff over and over again, and use those exact same people, the exact same mindsets, now I have a standardization. Now I'm getting better and better from project to project, and not just within my own one project environment. And then we go into mechanization. So as we're consistent, we're standard, then we can go to mechanize, and we can allow the machines to do the work for us. The reason that manufacturing, the reason that farming, the reason that all those things, that their productivity has gone up so much, is instead of picking the vegetables by hand, there's a big machine that comes by and picks them for you. Instead of hitting things with a hammer inside of a manufacturing facility. There's a machine that comes down and does all that for you. We need to find a way to do that. Consistency standardization is how we get to mechanization to be able to do that. As we look at these formwork systems, I want to stress that not one size fits all. Almost any formwork system can be productive given the right set of conditions. You make something, 8 foot high, very thin slab that's continuous. You can run down to the lumber yard and grab 4x4s and 4x6s. It's going to be productive. There's just nothing stopping it. It's easy. However, any of these systems that we're talking about can be extremely unproductive if given the wrong conditions as well. Using a more expensive system, we'll talk about from simple to more complex. Using a more expensive formwork solution for the wrong condition will not lead to higher productivity. You got to find the right thing for the right job and then have the right job conditions in order to do that. So the most important variable is the resources, the people. So utilizing that resource properly with the right formwork solution is going to be the key to success. So getting the people and getting the formwork systems working together, that's how we get there. All right, so we're going to start talking through some systems. So for those of you who know anything about formwork, none of these are going to be revolutionary. For those who don't know anything about formwork, I'm happy to introduce you. So talk about vertical. Vertical is often something that gets left out when talking about productivity, at least from a formwork end of things. It's there. It's what it has to get done, and so we just do it. But one of the things that can really help us is by having a self-climbing type of system. So what this does, it allows the machines to lift everything for you. You don't do the work. The machines lift from one floor to the next. Great mechanization. But for this, the walls must remain the same thickness and in the same arrangement going up. Added material cost for walls remaining the same thickness from the bottom to the top is insignificant compared to the cost of the people resources working to rework the forms. The efficiency of structural cross-sections does not lead to cost-effective, efficient construction and cost savings. There was a presentation, I think, yesterday where they were talking about how they did column design. And they took their, it wasn't PCA column anymore, whatever that design program was, and they take that, they threw in the information, that spat out some information, that spouted, put information directly into a column schedule, and away they ran. If they're changing those column sizes every single floor, level to level, that's going to add cost. Exact same thing with the walls. If you're trying to minimize your cross-section every time you go up, if you're trying to shift things and move things just in order to optimize those sections, that's great, but you can't use something like this when you do that. Or you can use something like this, and it just costs you more every single time you have to make a change. Changing things costs money, costs time, and we want to avoid that as we can. Standard sizes and shapes allow for off-the-shelf systems. One of the things that, for a system like this, where it gets pigeonholed into a very specific set of, to a location or something like that, is that it's very expensive. It's got a very expensive upfront cost. And for a contractor, they'd be like, well, I don't want to spend money on this. I can do it cheap just with forms, pick them up with the crane. But if you have something that's standardized, off the shelf, that fits with these sizes, that works. That's where you get the collaboration between the formwork contractor and your designer to know what those sizes are, know how it works, so that they can say, all right, I want this solution, put it on there, here's your price, and you're good to go. And obviously the mechanization point, this whole system moves at a push of a button. It's independent of crane schedule. The schedule isn't something I talk about a lot, but is very important as far as productivity gains. If you can have the crane doing other things for your flat work, and you can be moving your core independent of that schedule, that's even better. If you can do it mechanized, you're getting way ahead of the game. And you can use your people resources elsewhere, and you don't have to use them on the systems. All right, so let's talk about our flat work. And so now we're going to go from very, very simple to into some more complicated systems. So our modular drop head system, every single company has one of these. Changes in soffit, slab soffit elevation really cause lower productivity with this. You know, we know not every floor is going to be perfectly flat. That's not going to happen. But if you can keep it as perfectly flat as you can without interruptions, the system becomes better. I mentioned before continuity. If you can hand a person a pile of stuff and say, here's your pile of stuff, start here and go that way, putting these into V spacing, and you're going to come in and you're going to do that day after day after day after day, they're going to get really good at it. And that's going to increase productivity. If you're like, all right, go here until you reach this line, stop at this line, now put in a supplementary thing, now start a new line, now go to here, start another line, stop another line, so on, that's going to ruin your productivity very quickly. Nice thing about these is you have a handful of sizes, and so it's standardized. You're not going and going, all right, I have 50 sizes to deal with and 50 different things. You go in, you have a couple, you put it in, and you make it very easy. So consistency and standardization with both of these. This system has the drop head mechanism, which allows for the removal of the decking early before you remove the shoring. The structural engineer does have to approve this. So if you can do that, that is a great thing, because that allows you to move that framing forward, and you don't have to provide as much material. When you don't have to provide as much material, you don't have to provide as many hours in order to move that material. So it can be a good savings there. Going up the next step into a panelized system, from just a beam and joist kind of system, consistency in slab elevation is even more important, because here you're dealing with panels, and they're of a very standardized shape, and doing more custom solutions isn't as easy. This does eliminate open framing, reduces productivity loss due to fall requirements. So if you can have this open area where there aren't transitions to get all these panels put in from below, then you don't have all these people in situations where they're tying off, putting in to put in the plywood and go from there. Being able to use the standardized panels keeps them from having to cut plywood in. So if you don't have to ever leave what you're doing, working from below, putting that in, to leave, to go cut, to measure, to cut, to put in, try to fit, nope, that doesn't fit, let me cut a little bit more, and moving around. That reduces productivity. You can just have these panels that snap right into place, set, and that all relies on having things as uniform as possible. Even though these are set by hand, having the joists, stringers, and plywood all in one, that reduces the number of picks by the crane that you have to do. Again, that reduces material overall, that reduces time in order to move these things around. So the more that you can connect all your materials together, the fewer picks you have to do, and the less people it's going to take to move them. So speaking of connecting things together, our next system is our floor-mounted flying forms, or truss panels, as many call them. So these things are great. If I put these on every project, I absolutely would. They fill a full bay. You get up to 90 feet, or maybe a little bit more long. Fill a full bay with those. You pick them up the crane, you fly them out, you put them right back in. But the consistency thing with this is you need your columns and walls, all of your vertical, to be exactly consistent all the way through. You cannot change as you go up through there. If you change there, now you're having to do custom solutions every single time. So once assembled, these things are moved level to level. Limited number of people to do all of this. You do have to do a little interior framing, but other than that, it's all done as one. So very, very productive. These panels are strong enough to accommodate wildly varying slab edge from level to level. So you can see this project down below. This one in Seattle. It's got I think half the buildings in Seattle now have this profile that the slab goes in and out, which is, that's great. And if you can use a solution like this, those panels, they can accommodate that. They can move, that slab can go wherever it wants. The second you move the vertical in order to do something different, that's when you get into trouble. Again, the crane does all the heavy lifting. You will have to do reshores and supplemental shores in order to accommodate the intersections and certain things, but not too much extra work is needed. The next step from that is column-mounted forms. It's a very similar thing, but these are mounted to the columns themselves. Consistency is even more important with this. These really, you can't do any custom solutions once they're in the air. These you also want to stick to some standardization for them. The large girders you see there, those are of a standard size that you have to meet. So the bay widths you're going to have to look at and find out what the sizing on those should need to be. The columns themselves, you'll need to make sure the columns are of a proper size so that you can actually anchor the panels off to them. We've seen some with some very, very small columns, and you get loading on those and the column starts to move. So now you have to start bracing the column and dealing with that. Whereas if you go, all right, let's change the design a little bit, let's beef up the column, now we can have this thing fit in here, and we don't have to do all these other solutions. So increasing productivity there just through that small little design change, just by talking to your former contractor. And again, everything's put in place by the crane. There are no primary shores on these, so there are no reshores on these. So you're putting this deck in and taking it out, and there's nothing below. Because of all of that, all of your third-party trades can be right up behind you. So there's no loss from that of 2, 3, 4 floors of doing that. Having 2, 3 floors of outriggers that you have to move every single level and move around. So the productivity gains are great just by the switch from the floor-mounted system to a column-mounted one. Again, instead of if you could put these on every single job, our productivities would shoot through the roof in a minute. So some things on beams. So pan form construction has been around for a whole long time, and I think it should see some resurgence. Pans are a great way to have a stiff floor system, but reduce the amount of concrete that needs to go into it. The overall depth it can be pretty high, but the effective depth, so the amount of concrete you're putting on here is pretty low. So looking from a carbon reduction standpoint, pan systems are really good for these. So really what you're looking at is when you have consistent beam spacing, consistent and uniform, instead of putting in a soffit, or a beam soffit and slab soffit, instead of doing that, you form the void, form it with a pan. Pan construction, it can handle a lot of variability, but productivity increases if you can be very consistent. You can use longer length pans. You can have those as one piece. They work much better from a mechanization standpoint. If you can be flying them with the crane instead of placing them by hand. Also, removing them is much easier. You can remove them with a forklift other than removing them each piece by hand. So the bigger sections we can use, the better off we are. Standardization, again, obviously, is a big thing. We want to use the inventories we have. So talking to your contractor and knowing what they have to be able to use so you don't have to come up with a custom solution each time is a very good thing. Something that's gaining in popularity, especially in certain areas, is what we call the super wide pan. This is a solution that was kind of created in order to mimic the spacings from steel beam structures. So in order to convert steel projects over to concrete, keeping that consistent spacing that they're used to was something that was desirable. So coming up with these pans that are, instead of 53 and 66 inches wide, going up to 89, 99, 112 inches wide. By doing that, obviously you can put in a much bigger area all at once. You're flying these in with a crane, or you're moving them with a forklift, taking the stress off of the workers. These pans don't need decking underneath them. You frame at the ends, span the pan across the panels, you shore up between those. Again, you're reducing different operations to come up with a very efficient way of forming a void. Parking garage beam forms. These are nothing new, but consistency is pretty key for them. Parking garages themselves are pretty consistent with their designs, so that's not something that's unusual. Something we do see, though, is with the end columns. So if the end columns are of different sizes and those keep changing floor to floor, now your beam size keeps changing, or length keeps changing floor to floor, and you have to change that and accommodate it, maybe not from level to level, but from bay to bay to bay. So now you're having to swap where you're putting these things as you move through the building, adding time to move parts and pieces, coordination issues as well. Standard beam sizing is essential. Places have these in certain sizes, and we want to stick to those. So knowing what those are and being able to work with your formwork contractor between the designer to say, hey, all right, we need to change our depth a little bit to make this work, that we can do. Also, the beam and slab tables are all flown into place. If the beam spacing can be set as such that the slab tables can span between the two beam tables without any shorting in between them, then by doing that, you create this large open space. Excuse me. This large open space. You don't have to reshore if you don't have any shores in that middle area. So that creates productivity improvement. And also you have a wide open area for being able to move through yourself, much easier access to move these beams around through the building. It's a very simple thing of changing it by a foot or two for those spacings. It can have a big effect on the project overall. Not exactly a formwork system, but the perimeter enclosure systems, the barriers. Again, you see a lot of different companies have these, but they work very, very well if you have a very consistent slab edge location. This picture on the right does not have one, so they can accommodate other situations. But it is a big pain in the neck, and it costs every single floor. It costs effort and money to deal with that. But we know not all projects are going to be big rectangles like the one down to the left. A lot of times we'd like to see it that way, but we know that's not going to be the case. So if we can have that consistent slab edge, it's great. If not, we can make it work. But there's a loss in productivity. From a mechanization standpoint, all these things get picked up by the crane. It creates a cocoon around the building, which is nice from a safety standpoint, from a material falling standpoint. But one of the big productivity gains from it is that you have people feel safe. They feel that they're working down on the ground. Like they could be 50 floors up in the air, but they have the effect of working down on the ground. And that has a big change to your mindset. So you're just not in the active mindset of falling the entire time. So we do see productivity gains just from this simple thing of wrapping it in, putting some sort of coating on the barrier, plastic or something, so that they can't see out, keeps the wind out, makes for a very productive working environment. Another non-formwork thing, but like the goals to where we're all kind of wish we could go, is to some sort of robotic assistance with formwork. So there are things from very rudimentary up through very advanced, but the use of mechanization and robotics in manufacturing is a big reason why they can get the productivity they can. The reason that they do that is that they have the exact same process over and over, the exact same way, in the exact same conditions every single time. And so if we can do our best to replicate that, every single day the worker comes in and does the exact same thing, well, if we can get to that point, now we can start figuring out how to mechanize that. All right, to review, consistency, standardization, mechanization provide the opportunity for innovation by giving these opportunities through consistency and standardization, and work with your formwork contractor. Even if it's not a design build, even if you don't get the formwork contractor on board early or the general contractor, I guarantee you that there's a formwork contractor in your neighborhood who wants to talk to you. They would love to be involved. Yeah, they may not get the job, but they know that moving the industry gets us further. If not, if you don't have one near you, you can call me. I'd love to talk to you. We'd love to help you out. So I want to say thank you to Phil and Pro for inviting me. I'm the committee chair of 347, so we're trying to keep these things in mind and trying to keep innovation in mind and really trying not to get in the way of innovation. Is something we're trying to do. So if you'd like to join us sometime, that'd be great. All right, that's all I got. Thank you, Phil.